Smile please.
Good evening, my dear students and the entire community. Congratulations, I think you would have written GATE very well, and we from ACE Engineering Academy and ACE Online welcome you to this live presentation on solutions to GATE 2025 Electronics and Communication. Myself B.S. Krishna Varma, faculty, as well as with the most experienced and senior faculty members of Electronic and Communication. We would now like to start this live session on clear and accurate solutions to the GATE 2025 Electronic and Communication Engineering paper. Yes, I would like to give just information on the approximate number of questions in each subject with the data as on available from the memory of students, and still we are updating with more accuracy as and when we get the feedback. Yes, this is a solution video for GATE 2025 Electronics and Communication Engineering. Now, as per the data latest available, now these are the number of questions in each subject. Like network theory, we got 2 1 marks and 2 2 marks. Control systems, yes, 2 1 marks and 3 2 marks questions. Electronic devices, yes, see, highly dominant, 2 1 marks and 5 2 marks. Analog circuits, yes, see here 4 1 marks and 3 2 marks. You know this is core, right? Digital electronics or digital circuits is again 3 1 marks and 3 2 marks. Signals and systems, 3 1 marks and 2 2 marks. Communications, yes, the most powerful, dominant in electronics, 4 1 marks and 5 2 marks. Electromagnetics, 3 2 marks questions. General aptitude and engineering mathematics. Okay. So with the latest accurate data available, these are the number of questions in each subject, and approximately, yes, total questions we got numerical analysis type 12, MCQ 39 and MSQ 14. Now, yes, we would like to start the solution in each subject with the experienced faculty members of ACE Engineering Academy. Stay tuned.
Guys, good evening guys. I myself K. Hanumantarao, network faculty, and in network 4 questions are given totally, 2 1 mark questions and 2 marks questions are given. Out of that 2 MCQs and 2 NATs, numerical analytical type. Let me discuss one by one. Guys, the first question, consider a part of electrical network as shown below. Some node voltage and current flowing through the 3 ohms resistor are indicated. The voltage node X in volts is. This is our required value, and here this is the X node, this is the node X, this voltage you have to estimate here. This is very simple guys. You may have some confusion regarding the voltages are provided, and once you see that this is the 9 volts and this is the 8 volts, as per the data provided you are able to define the voltage across the 3 ohms resistor, that is 3 into 1 3 volts, and using this you can easily identify the voltage across this node or at this node. That voltage you can take it, this is positive and this is negative. The total voltage with reference to this you are able to define as 6 volts. If you want to get it that voltage across the X node, then definitely you should know that the current how much it is in between 2 ohms and 1 ohm. That you can easily identify that as you know that the current is from higher potential to lower potential. That is why I can say that 8 minus 6 2, the net resistance both 2 and 1 are connected in series, and with this I can say 2 by 3 amperes passing through the 2 ohms resistor and 1 ohm resistor. As per the direction and according to the resistors are given, I am able to define that polarities and voltage value. That is here 2 by 3 into 2, that is 4 by 3 volts, and 2 by 3 into 1, that is 2 by 3 volts. This voltage is required here. If you want to get it that voltage with reference to the 6 volts or with reference to the 8 volts, you will get the same value. That resultant by KVL, you can get it that here minus Vx and plus 2 by 3 volts and plus 6 is equal to 0. Guys, with this you are getting that Vx is equal to 3 into 6, 18, 18 plus 2 is 20, 20 by 3 volts. You can also check it the same one with respect to this one, you will get the same, that is minus Vx, minus 4 by 3 and minus 8, plus 8 you are getting. With that one also you will get the same thing. This is under NAT, numerical analytical type, that is why the answer is 20 by 3 volts, right. This is the 1 mark question given. And let me consider the next one. Guys, this is the 2 marks question and this is the MCQ question. It is very simple, you can easily identify that. Here the question is, let IC, IL, IR be the current flowing through the capacitor, inductor and resistor respectively as shown in the given figure. AC admittance is given Siemens. Which of the following is true? You need not go for any calculation part here, directly you can take it here. Since the current passing through that anyone is equal to, as per the formula, IC is equal to or I is equal to V into Y, where Y is the admittance. That is why you can easily identify that IC is equal to V. V is given 1 at an angle 90 degrees, okay, and IC value 0.25 Siemens into J, nothing but that you can write 0.25 at an angle 90 degrees, you are getting that 0.25 at an angle 180 degrees amperes. While coming to that IL, similar way we can take it, voltage, applied voltage is 1 at an angle 90 degrees and the admittance was provided here minus J 0.15 Siemens, with that 0.15 at an angle minus 90 degrees. This we are getting 0.15 at an angle 0 degrees you are getting amperes. While coming to that IR, same formula we can take it, that is V into nothing but 1 at an angle 90 degrees into 0.2 Siemens, that is 0.2 at an angle 0 degrees. Now 0.2 at an angle 90 degrees amperes. If you verify that according to the given options. Here this is 0.15 and 0.25 and 0.15. 0.1 is given for all, might be this is 0.1 Siemens. Under that I can say that option A is the correct one. Option A is the correct one. See that this is 0.2 at an angle 90 degrees and 0.1 at an angle 0 degrees and 0.25 at an angle 180 degrees. If these are the correct options, this might be the 0.1 Siemens. Okay. This is a 2 marks question, MCQ given. Let me consider the next one. Right. The question is the Z parameters matrix of the 2-port network relates the port voltages and port currents as follows. Z parameters matrix is given, relation is given. The Z parameters matrix in ohms of the network shown below. The Z parameters matrix you have to estimate. This is also given in terms of here MCQ, under MCQ given. Guys, this is very simple. Here you need to go for only one simplification technique, that is from star to delta and delta to star. As per this, if you are able to perform the delta to star transformation by this simplification, you will get the direct answer. You know that from delta to star, whenever in delta Z is there, then definitely you will get the equivalent star network as Z by 3. With that I can say here this is 2 by 3, this is 2 by 3 and this is 2 by 3. With this we are going to get it that the entire network as a standard format, that is a T network. I can write that a T network, standard network, because as you know that once T network is there, we are able to define directly the Z parameters. This is 2, 2 by 3 and 2 by 3 and 2, this is 2 by 3. These two are in series, that is why you will get this is 8 by 3, these two are in series, you will get 8 by 3. And as per the standard T network, by taking the KVL for this one, Z1 plus Z2, 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 Z2 plus Z3. According to that, I can take it the Z parameters matrix is equal to Z1 plus Z2, 8 by 3 plus 2 by 3 and Z2, 2 by 3 and 2 by 3, 8 by 3 plus 2 by 3. Since this is the symmetrical and reciprocal network, that is why I can say that here 10 by 3, 2 by 3, 2 by 3 and 10 by 3. As per the given options, all are having that reciprocal and symmetric, but as per the given, I can say that option C is the correct one. Option C is the correct one. This question is MCQ under 1 mark question. Let me take the next one. Right. The next question is, in the circuit below, M1 is the ideal AC voltmeter and M2 is the ideal AC ammeter. The source voltage is Vs is equal to 100 cos 200 t. Then the operating frequency is given. This is the omega 200 radians per second. What should be the value of the variable capacitor C such that the RMS reading on M1 and M2 are 25 volts and 5 amperes respectively. Guys, here the diagram is not provided. If you see the diagram, he was provided the diagram is like this. This is M1 and this is M2, both are the ideal meters here, and this is the reading as given as a 25 volts and this one is 5 amperes is given, and applied voltage is Vs, and this is 5 ohms given, and this one is 1 Henry is given, and this is the capacitor is given. Guys, according to the question, once you see the question, and it is given as LTI circuit, linear time invariant circuit. See guys, in the circuit M1 is the ideal and M2 are the ideal. We need to estimate the value of what should be the value of the variable capacitor, and as per the readings are given M1 and M2. You know that guys, whenever across any load circuit, by knowing the applied voltage and resultant current, we are able to define that the value of total impedance. The total impedance Z is equal to what? Applied voltage and resultant current ratio. But here this is the AC circuit, it did not mention that whatever the phase angle is given. That is why I need to go for the magnitude. As per the magnitudes, I can say that applied voltage is equal to 25 volts and resultant current is the 5 amperes. So we are getting that 5 ohms. According to that given here, this is RLC series circuit here. According to that RLC series circuit, he was given that L value is in terms of henries, then the operating frequency is given. As per the source voltage here, see this, operating frequency is equal to 200 radians per second. According to the 200 radians per second, I am able to define that inductive reactance, that is XL is equal to, or JXL, impedance across pure inductor, J into 200 ohms. As per this, we are able to define that the magnitude of RLC series circuit is equal to under root phi square, nothing but R square, XL, nothing but 200 minus XC whole square. If we equate like this, we are getting here, this is 25 is equal to 25 plus 200 minus XC whole square. From this, I am able to define that XC value is equal to 200. Guys, from this XC value is equal to 200, you are going to get it, where XC is equal to 1 by omega C is equal to 200 and C value how much? 1 by omega. Omega value is given right. Omega value is given here 200. Right. This is 1 by 4 into 10 power minus 4. This you can write 100 by 4 into 10 power minus 6 here, 25 into 10 power minus 6, 2.5, 25, right. Now here you are getting the 25 microfarads. C value is equal to 25 microfarads. According to that options, this is under NAT is given, that is why, right, 25 microfarads as per the given options, C is the correct one. Okay. These are the questions given under NAT. These are very simple questions here. Definitely you will get 6 out of 6 marks. All the best. And next, the right analog circuit faculty Trinath sir is going to continue the next session. Okay.
Hi dear students, Namaste. This is MM Trinath. I am one of the faculties of Electronic Devices and Analog Circuits in ACE Engineering Academy. I hope you gave up today's exam. Awesome, right? So electronic devices, I understand we got approximately 12 marks, and analog circuits, it is almost like a 10 marks. 22% weightage in both subjects is amazing what I understand. So go with the questions what our students has given as input. So the first question, in analog circuits, I think examiner has provided a negative feedback system under common emitter configuration. It is 3K and it is a base bias with a collector feedback. Am I right here? Base bias with collector feedback. Of course, it is completely a DC circuit, so no need of disturbing the sources what we have here. If it is AC circuit, as we discussed a lot, this must be a negative feedback with a shunt mixing, and like shunt mixing, input must be current and output is a shunt sampling, output must be voltage. It must behave like a trans resistance amplifier. Am I right here? Anyways, this is given as what here? This is 10K, 10 volt supply, and here what is the question examiner is asking? Beta F is provided, I hope, as per the data. It is 100, and IB, the base current, examiner has given as a 10 microampere. If I am not wrong, he is asking to find the value of VCE. Am I right here? VCE is how much? I think I am right. So how can you are supposed to find this answer? It is very easy question. First of all, you please understand the current which is passing through the emitter terminal, if you ask me, that will be emitter current. And this is the collector terminal, it is a collector current, and this is the base current. Then no doubt this will be again emitter current. Am I right here? So try to apply the KVL from here with respect to the ground. Could you please apply KVL, dear students? So 10 is equals to emitter current into 5K, and as current is entering, I can say this is plus and minus. This voltage will be VCE. Am I right here? So it will be plus VCE, right? And it is plus IE into 3K. True or not? I think almost we are done with this question. So, right. Now tell me, dear students, it is how much? So 10 is equals to 5 plus 3, 8K into examiner has provided IB. I hope you know IE is nothing but how much, dear students? 1 plus beta F times IB. Am I right here? Beta F is 100, therefore it is 100, right? So 8K into 100 into I'm going to say 1 plus beta nadir, so it must be 101 into IB. IB is how much? 10 micro plus VCE. That's it. I hope we can able to find the answer from here. By solving, I understand we are getting 1.92 volt. You please check it out whether you got the same answer or not. So the answer for this given question is 1.92 volt analog circuits. Okay, let's go with one more interesting question asked in analog circuits. I think examiner has given an amplifier equivalent circuit, design. Number of times we discussed about the designs of your analog circuits, right, dear students? So this is RS, source resistance, and input voltage is provided, and I hope this is R pi, which is nothing but what here? Beta F times RE, or 1 plus beta F times RE. Hope you remembered in the class. And this is given as beta F times IB. Am I right here? Hope it must be grounded, right? And here RL is provided. And from here we are supposed to find the output voltage V naught, not output voltage I believe, we are supposed to find the gain. So gain of the small signal design is how much? So V naught by Vi is how much? I hope this must be the question. If that is the case, it is very easy question, guys, right? Tell me, dear students, this will be the IB value. Am I right here? Could you apply KVL at input? What I am going to get? Vi is nothing but IB into RS plus R pi. Right, dear students? And what is V naught? V naught is as simple as minus beta F times IB into how much, guys? It is like, yes, this is simply RL, so it is RL. So as per the data what we got from our students, RL value, RS value is not provided, and R pi also not provided by the examiner, right? Then what could be the voltage gain here? AV is nothing but V naught by Vi. Tell me, dear students, it is as simple as like minus beta F times RL whole divided by RS plus R pi. That's it. So this is the voltage gain what examiner is asking, right? And the very interesting third question, I think it must be a 1 mark question. Let me read out the question. You please check it out. So identify the correct statements about ideal operational amplifier. Examiner has provided the data such a way that option A, infinite output resistance. So examiner clearly asking ideal op amp. He is asking about what, dear students? Ideal operational amplifier. So whenever I say ideal op amp, I hope you know input resistance must be equals to infinite, output resistance must be equals to 0. And differential gain, or we say open loop gain, must be equals to how much, guys? Infinite. And you can say CMRR, common mode rejection ratio, must be infinite, indicates common gain or a noise gain or a common mode gain must be taken as how much, guys? 0. I hope you recollected it, right? Now check out the first option. Examiner is provided infinite output resistance. I think operational amplifier output resistance must be 0, not infinite. So option A must be wrong. Okay, in option A, examiner is provided infinite output resistance, which is wrong. Whereas in option B, infinite input resistance, option B must be correct. Infinite input resistance. Yes, absolutely, input resistance is infinite. And option C, infinite open loop common mode gain. Infinite open loop common mode gain. No, common mode rejection ratio must be infinite, not common mode gain is infinite. So, common mode gain must be 0, therefore, option C is wrong. And infinite open loop differential gain, that is right, differential gain, open loop gain must be infinite. This is apt. So, option D is apt, no doubt. So, I think this must be MSQ, multiple select questions, option A and option D must be the right answer. And one more question what I got from my student from electronic devices. Okay, from electronic devices, if you ask me, examiner is asking n-type dopant. Okay, n-type dopant, you know, option A phosphorus, option B arsenic, option C gallium, and option D boron. Am I right here? Very simple question. I hope you know. If I go for intrinsic semiconductor, fifth group elements must behave like a dopants for producing n-type semiconductor. Arsenic, antimony, phosphorus, bismuth. Am I right here? So, phosphorus is correct, arsenic is correct, and absolutely gallium and boron must be wrong. Why? Because indium, gallium, boron, aluminum must be dopants for third group to produce a third group p-type semiconductor. Am I right here? So, it is also a multiple select questions. And more questions we are going to get from analog circuits and electronic devices. I am waiting for the questions. Okay. So, meanwhile, my colleague will be continued. Thank you.
Good evening, students. I am Dr. Shiv Subramaniam, Faculty for Electronic Devices and Circuits. See, there are two questions we got from till now. Two questions we got from the electronic devices. One question already Mr. Trinath has been discussed. One more question, again it's a very simple question, 1 mark question. It's based on your Einstein's relation. So, usually we will take d by mu is equal to Vt, right. So, this is the diffusion constant, the mobility, and this is the thermal voltage. So, ratio of these two will be thermal voltage. So, I think they have given dn and mu n value, right. So, from this one, sorry, dn and Vt. So, dn is what? Mu n into Vt. So, mobility is given, thermal voltage is also given. So, just you have to multiply the two, that will give you the value of dn. So, till now this is what we have. Still we need to get 5 more 2 marks questions from the electronic devices. So, once we get that we will discuss. Thank you. So, next control systems, Nageshwar Rao sir is going to continue.
In controls 5 questions asked, total weightage is 8 marks. This is the one question related to the root locus diagram. Is asking the k value at this pole location at s equal to -1 plus j1. What is the k value they are asking? This is the pole location, they are given at what? -1. The given point is here. This is the point.
So, this is minus 1 plus j1. So, there is no chance of this point lies on the what root locus. So, that means what? No positive value of k exists for that pole location or given point. The no positive value of k exists for the given point. So, option D is correct. Next, this is the question belongs to the controller, PID controllers. So, as we know it, integral controller, this is the transfer function of integral controller. So, integral controller added pole at origin. So, due to pole at origin, the system becomes the unstable. That means what? There is no controller, there is no integral controller which makes the system stable. So, that means this statement is correct. And PD controller, as you know that it add a what? One finite zero which makes the system is stable. So, there is at least one PD controller which makes the closed loop system is stable. That means both the statements are correct. So, remain questions continued by my colleague.
Yes, dear, good evening students. Now this is an Nyquist plot. A very simple question here. Observe. Now from this data, what is the examiner is asking? Gain crossover frequency and phase crossover frequency. No doubt it is a negative real axis minus 180 degrees, where the point is touching at the minus 180 degrees. The plot is touching at minus 180 degrees is called the phase crossover frequency. So at Q it is a phase crossover frequency. At Q it is a phase crossover frequency. Now wherever it is touching the unit radius circle here, unit radius circle 1, minus 1g magnitude is 1. So where it is touching at S. So at point S here, it is a gain crossover frequency, So what is the correct option here? At omega Q, gain, now options observe C, at omega S is a gain crossover frequency, omega S, at omega Q is a phase crossover frequency. So best suitable option is option C is correct answer. Here, suitable option is C is correct answer. Now one more question here, simple question it is. Block diagram is given, is asking to convert into signal flow graph. There are two methods. First, convert into block diagram to signal flow graph, or you can find the overall trans function here and check the overall trans function. Now I am converting block diagram to signal flow graph. It is R. Let us, this is a node N1. Now this is a node N2. This is a node N3 here, node N3, node N4 here. Now last C. So I am writing here R. Now N1. This is N1 node here, N1 node. Now N2 node here. Next to N3, now N4, last C here. Observe from the block diagram, R to N1 nothing is there, so path gain is 1. Next to N1 to N2 also, okay, 1. N2 to N3, path gain is G1, N2 to N3, the path gain is G1. Now N3 to C, N3 to N4 also nothing is there, N3 to N4 also, now last C. Next to N2 to N4, N2 to N4 is G2, N2 to node N2 to N4 is path gain is G2. So from N3, node N3 to N1 with the negative N3 to N1, the path gain, okay, minus 1. So from here best suitable answer here, now check it here, minus 1. So option A is correct answer. These are the questions from the control systems.
per the info given by students, I think from signals we got 3 1 mark, 2 2 marks questions. Let us observe. The first question is, let f of t is a periodic signal. This is not Fourier transform having fundamental period. It has the time period t naught. Time period is mentioned. So, when it is scaled, f of alpha t, their individual coefficients are given like this. F of t coefficient is ck, yt coefficient is dk. With that information, which are the correct options? Generally, if xt coefficient is ck, the scaled signal coefficient also remains same. What differs? Only the frequency differs or time period differs. For the scaled signal, the frequency becomes omega naught to alpha omega naught. According to the given option, he is saying ck is dk for all k. To be specific, this k is multiple of omega naught in the case of xt. In the case of y of t, it is multiple of alpha omega naught. Of course, there is no change in the coefficient amplitude, only the x-axis differs. So, we can feel this is correct. Yt is periodic with fundamental period of t naught by alpha. That is also true. Original signal time period t naught, here it becomes t naught by alpha. As B is correct, automatically C is wrong. And we observed that there is no change in the amplitude level. Based on that, this is also wrong. So, first two options are possible. Okay. Let us see the next model. Yeah. Fourier transform definition is given. Which of the following statements are true? This absolute integrability is a sufficient condition that we are aware. Convergence of Fourier transform based on its definition. Once you take modulus to the definition, integral magnitude of e power minus g theta becomes 1. So, we are left with this. So, less than or equals to integral mod f t dt, that is correct. Less than or equal to is the correct one. So, this is failure. This is also failure. Last one also may be correct, because he has concentrated on what? Magnitude of the spectrum greater than or equals to. What is the indirect meaning of integral f t dt? This is indirectly means spectrum at origin. This indirectly means spectrum at origin. As example, to highlight the last option, assume we have chosen a reference spectrum something like this. So, it has a peak amplitude at a frequency like omega m, whereas at 0 it is 0. So, maybe option D is also true. Option A and option D both are valid options. I think we got one more model related to sampling. As per the information given by students, I do not have a perfect idea because they have not given the data correctly for us. Some band limited signal spectrum is given on sampling, band limited signal spectrum. Later on, he wants to pass through periodic impulse train. When this data is passed through some filter, ideal low pass, what is the condition on sampling frequency or sampling rate to recover the original signal? Some options are given, but so many students are unable to give the data thoroughly. So, as per the information available from students, these are few questions. I think one more question is there. It is handled by Mr. Srikanth.
Thank you, sir. One more question on signals and systems. It's a MSQ question from DTFT. See the question, let x of n be a discrete time signal whose Z transform is capital X of Z. Which of the following statements is or are true? It's MSQ question, 1 mark. First option is given as DTFT exists if the ROC contains unit circle, correct. For stable signals, only DTFT exists. It is a property of the ROC. For stable signals, ROC includes unit circle, correct. So, first option is correct. See the second option, DTFT of x of n always exists. No, it does not always exist. Let us take one example, 2 power n u of n. DTFT does not exist for this signal. Okay? Yes. So, this statement is false. See, ROC of x of z contains neither poles nor zeros. ROC doesn't contain poles, it may contain zeros. Yes, so this is also wrong one. Last one, if x of n is alpha into del of n is a unit impulse and alpha is a scalar, then the ROC is entire jet plane. Correct, because what is alpha into del of n dt of t? It is alpha. What is ROC of this one? Entire jet plane. Yes, this is also correct. So from the given options, A and D are correct options. So these are few questions from signals and systems as per the data given by the students. And next, Kiran sir will continue the session.
Okay. Let us look at analog circuits. A clipper circuit is given. Now you are asked to find the time duration, find time t for which the diode is on. This is the question, and the input given is 10 sin 100 pi t. Okay. So now we know whenever the anode voltage is greater than cathode voltage, diode is on. Whenever the anode voltage is greater than cathode voltage, diode is on. When the diode is on, the output is restricted to minus 5 volts. Okay. If Vin is less than minus 5, diode is off, output follows input. Now what is the question? The question is you have to find the duration for which the diode is on. Now this similar problem was also already given in GATE exam, and we know that this duration, we were asked to find the duty cycle. If you remember, this duration is 1/3 of the total value. Then the portion where the diode is on is going to be 2/3. This portion is going to be 2/3 of the total value. Okay. But what is the time duration? This is of the form Vm sin omega t. Omega can be written as 2 pi by t. So if 2 pi by t is 100, then t is going to be 0.02. Okay. So the solution is 2 by 3 of 0.02. This is a solution, which is 4 by 3, which is 13.3 millisecond. So this is the answer. But if you want to find a sine function gets half its value at 30 degrees, right, pi by 6. So if this is pi plus pi by 6, and this is 2 pi. So, this duration is going to be 2 pi minus pi by 6. So, you can find that this is 120 degrees and the period for which it is on is 240. So, what is the comparison of 240 with 360? 2/3 of the value. So, 2/3 into 0.02 is 13.3 millisecond. So, this is the first question. Now, the second one is calculate the upper cutoff frequency if the lower cutoff frequency is given as 1 megahertz. Now, the given circuit is a band pass filter, you are asked to calculate the upper cutoff frequency. So, R1 is given, C1 is given. So, let me see the values. R1 is R, C1 is 10C, R2 is 2R, C2 is 0.1C. Okay. So, how to find the upper cutoff frequency? Now, this is a band pass filter. The shunt arm will always decide low pass and the series arm is going to decide the high pass. So, the difference is the band pass. This duration is given, which is 1 megahertz, which is 1 by 2 pi R1 C1. Now, you are asked to find 1 by 2 pi R2 C2. Now, if you wish you can calculate, but by comparison this is 10 RC, by comparison this product is 0.2 RC. So, what do you mean by this? You can see the difference between these two is 50 times less, 50 times. So, from here to here you can see this is 50 times less. So, now the inverse is the answer should be 50 times more. So, FL is 1 mega, so this should be 50 mega. If you wish you can calculate, but it is a simple logic here. This is 1 mega, for 1 mega the value is 10 RC. Now, you want 0.2 RC, so it is 50 times less. So, obviously, the upper cutoff frequency should be 50 times more. So, this is the second solution. The third one is identify the correct statement. Identify the correct statement. Common source amplifier has infinite input resistance. Common gate amplifier has infinite input resistance. Common drain amplifier gives no phase shift. No phase shift. Phase shift. When you say phase shift, it is between V0 and Vin. And common source amplifier gives phase shift. So, this is the question. Okay. So, common source amplifier, if you see the input is given at the gate terminal where the current is 0. So, if the current is 0, the resistance is infinite. Common gate amplifier input is at source. So, at source terminal there is some current. So, there will be a finite input resistance 1 by Gm. So, this option is wrong. Common gate amplifier gives no phase shift, which is correct. It is similar to common collector amplifier. Common gate amplifier gives, common drain amplifier gives no phase shift. Common source amplifier gives phase shift. So, this is also correct. Common source is the only amplifier which gives phase shift. Common drain gives no phase shift. So, this is the correct option. So, next find
find V3 if GM is 5 milliampere per volt. GM is 5 milliampere per volt. This is a differential stage given. In this differential stage, the tail current is 2 milliampere. So, the input here is 2.5 plus 0.01 sin omega t. The input here is 2.5 minus 0.01 sin omega t. The drain resistances are 1 K. You are asked to find V3. You are asked to find V3. So, this is the solution. Now, you can see this is 2 milliampere. So, the current will split into 1 milli and 1 milli. So, what is V3? V3 DC is going to be VCC is given or VDD is 5 volt, 5 minus 1 milli into 1 K, it is 4 volt. So, the DC part is done. Now, you are asked to find the AC part, because according to superposition theorem, the V3 is V3 DC plus V3 AC. Since we are applying a small signal, so V3 DC plus V3 AC. So, now what is V3? V3 by VD is half of minus GMRD. Minus GMRD, this is a standard formula for a differential amplifier. So, V3 by, what is the difference? 0.01 minus of minus 0.01, 0.02 sin omega t is 1 by 2 times GM is given, RD is also given. So, now your V3 is going to be minus 0.05 sin omega t. So, what is the total V3? The solution is V3 is V3 DC plus V3 AC, 4 minus 0.05 sin omega t, 4 minus 0.05 sin omega t. So, this is the solution. A simple bridge rectifier is given. You are asked to draw the transfer characteristics. So, the transfer characteristics is quite simple. You know, output follows input for. So, now in this problem you are asked to draw the transfer characteristics V naught versus V in. So, during positive cycle, these two diodes will get on, positive cycle, your output follows input. What happens when V in is negative? When V in is negative, these two diodes are on, but the current direction is same. So, your V naught is minus of V in. So, what will be the transfer characteristics? V in on x axis, V naught on y axis. So, output follows input, y equal to mx, and for V in negative, your V naught is positive. So, this will be the simple solution. One last question. Find R1 and R2. Find R1 and R2. The circuit is given. So, the data given is VEB is 0.7, VEB is 0.7, Zener voltage is 5 volts, the load current IL is given 12 milliampere and the Zener current is also given 25 milliampere, and beta is 120. So, this is the given data, this is a given data. Now, you are asked to find these two resistor values. So, now you can see 20, this is 0.7 and 5,
20 minus 5.7, this is going to be 14.3 volts. So, the voltage here is 14.3. Now, you can apply Ohm's law. Resistance is voltage by current, but how do you find the current here? This is 12 milliampere. So, the base current will be 12 milli by 120. So, it will be around 0.1. This is 25 milli and 0.1. So, this is going to be 25.1 milli. So, according to Ohm's law, what is R1? R1 is 14.3 divided by 25.1. So, it is around 0.6 K. I have calculated this. It is around 0.6 kilo ohms. Now, he wants R2 also. This is again 0.7. If you go up, the voltages will add. So, 14.3 plus 0.7 is 15 volt. So, already 20 is there, 20 minus 15 is 5 volt. So, what is the solution? R2 is going to be 5 divided by this current, already 12 milliampere is there, emitter current is going to be 12 milli by alpha, it is approximately 12 milli only. So, this comes around 0.4 K. Okay. So, these are the questions in analog circuits. Thank you.
Hi, myself P. Venkatrao, faculty, Mathematics, ACE Engineering Academy. So, some of the questions I received from students community. So, we will discuss these questions, and I am not sure about the functions what I have received. So, I am not sure about the question regarding what the students have sent exactly. Whatever the questions, these are purely memory based questions. Question number 1 from calculus, and it was given f of x equal to 2x cube minus 3x square minus 12x plus 1. Actually, this is the question, and we were asked to find it has local minima at so and so point and local maxima at so and so point. That is the way the options were given. So, regarding local maxima or minima, first of all you have to find f dash x. So, f dash x is x cube derivative 3x square into 2, that would be 6x square minus 3 into 2x, that is 6x minus 12. So, obviously f double derivative of x is only 12x minus 6. So, in order to get the stationary points, first derivative is equated to 0, so that it becomes 6x square minus 6x minus 12 equal to 0. So, from this x square minus x minus 2 equal to 0, what are the values of x satisfying this equation? So, x equal to minus 1 whole square 1, 1 plus 1 2, 2 minus 2 0, another one is 2. So, minus 1 comma 2, these two are the stationary points. So, find double derivative at every stationary point. F double dash of minus 1, f double dash of minus 1 is negative, f double dash of minus 1 is minus 18. So, whatever it is negative, means less than 0, therefore, it has maximum value at x equal to, I mean local maximum at x equal to minus 1. Similarly, find f double derivative f double dash x at another stationary point, f double dash of 2 is 12 into 2, 24, 24 minus 6, 18. So, that is positive, positive means greater than 0. So, positive means f double dash of 2 is greater than 0. That means f of x will have, that is f of x will have minimum value at x equal to 2. So, some of the options minimum at 2, maximum local minima at 2, local maxima at minus 1, and that is the way they gave the options. So you have to select the proper option then. And one question, so regarding the question they gave, A equal to 1 1, B equal to 0 3 root 2. This is the question, and we were asked to find minimum value of norm Ax minus B. So this is called norm Ax minus B. Norm means magnitude, magnitude means length. So what is the minimum value of normalization of Ax minus B? So first of all, Ax minus B, Ax is xx minus B, that is 0 3 root 2. So that is x minus 0, x minus 3 root 2. So this is Ax minus B. Norm Ax minus B means simply magnitude of Ax minus B only, square root of x square plus x minus 3 root 2 whole square. So this is the function we were asked to find the minimum value of this norm Ax minus B. That internal modulus function, that under root function, let it be f of x, that is x square plus x minus 3 root 2 whole square plus x minus 3 root 2 whole square, that is equal to x square plus x square plus b square means 9 into 2 18 minus 6x root 2. This is f of x value. So f of x equal to, this is a 2x square minus 6x root 2 plus 18. So find f dash x, 2 into 2x, that is a 4x minus 6 root 2. So we were asked to find the minimum value. Unfortunately, we got only one stationary point. Obviously, this minimum value should occur at that stationary point only. So to get that stationary point, simply write f dash x is 0, then it is 4x minus 6 root 2 equal to 0, 4x equal to 6 root 2. So x equal to 6 root 2 by 4, that is 3 root 2 by 2, that is 3 by root 2. Therefore, we got minimum value at x equal to 3 by root 2. Suppose you wish to find what is that minimum value occurring at the stationary point, substitute that stationary point in the given function, you will get the required minimum value. So therefore, the required minimum value, if you want, simply put that x equal to 3 by root 2 in the given function. This is the function 2 into 3 by root 2 whole square, 2 into 3 by root 2 whole square, 3 square by root 2 whole square 2 minus 6, x is 3 by root 2 into root 2 plus 18. You observe this 2 cancel. So this is a 9. So root 2 cancel, minus 18 plus 18, 18 cancel, this is 9. But f minimum, actually the function that we wish to minimize is this function, not that function, that is square root. So that is the square root. So square root of this function, so square root of this function, so that is root 9, that would be 3. And moreover, one question was asked like this in the GATE exam. Suppose 2 dice are thrown and some of the numbers on 2 dice are identified. What is the expected value of sum of the dots on 2 dice? If 2 dice are thrown, expected value of sum of the dots on 2 dice, it's a standard question, answer 7n by 2. Remember, whenever you wish to find expected value of sum of the dot, if 2 dice are thrown, then the expected value of sum of the dots on 2 dice, standard question, answer 7n by 2, where n is number of dice are thrown. N number of dice are thrown, 2 dice are thrown, so therefore it is 7 by 2 into 2, therefore 7. Therefore expected number of sum of the dots on 2 dice is simply 7. And one more question we were given like this. A pot contains 4 balls in which 2 black and 2 red, and they said 2 balls are drawn one after other without replacement. What is the probability of both balls are of different colors? Both balls are of different colors means probability first black, second red, second possibility first red, second black. First black 2 by 4 and balls are drawn one after other without replacement. Right now 3 balls only remaining, because the first time black is drawn we have only 1 black and 2 red, altogether 3. Now red is drawn, 2 by total 3. Now first red drawn, next black is drawn, that is 2 by 4 into 2 by 3. After simplification you will get 2 by 3. You can simplify that, 1 by 2 into 2 by 3, 2 cancel, 1 by 3, 1 by 2 into 2 by 3, 1 by 3. So 1 by 3 plus 1 by 3, that is 2 by 3. And one more linear algebra question was given to be, this is the last question. The question is A equal to 1, 2, 3, 4, 0, 5, 6, 7, 0, 0 alpha, beta, 0, 0, 0 y. So the question is, if the matrix has, if rank of the matrix, if rank of matrix is at least 3, if rank of matrix is at least 3, then what are the possible values of alpha, beta and y? So these are the options. Alpha not equal to 0, beta not equal to 0, y not equal to 0. Option B, alpha 0, beta not equal to 0, y equal to 0, alpha 0, beta 0, y 0, and so on. So options were given. So now you observe, if you want rank should be at least 3. That means if rank of the matrix is, it's already in echelon form, rank equal to number of non-zero rows. Before that, for what values of alpha, beta and y, your rank should be 3 or more than 3. That is the meaning of minimum 3 or at least 3. So according to the available options, alpha not equal to 0, actually alpha not equal to 0, beta can be any value. Beta can be any value. In all the cases where alpha not equal to 0, we were not given any option regarding beta any value. So that's why if I take alpha not equal to 0, beta not equal to 0, y not equal to 0, this is non-zero, this is non-zero, this is non-zero. So in that case rank should be 4. Rank should be 4 means rank is at least 3. 3 or greater than 3. In order to match the options, we are getting only alpha not equal to 0, beta not equal to 0, y not equal to 0. So according to this, therefore option A is the right answer. Thank you.
Okay, here is the questions which are related to the electromagnetic theory. So the wording, exact wording we do not have. These are the things we got from our students, fine. So here the options are provided anyhow. This is a surface charge is given. He is asking for the total charge over the specified surface, fine. So the surface charge density here, it is rho s. So how do you find out the total charge? You need to perform the surface integral. So the surface integral of, it is 4, it is the modulus of y. This is placed, this surface is placed in the xy plane. So what is the differential area? It is dx dy, correct. So here you can just perform the integration over the single portion and you can multiply with the 4, number 4. Why? Because the modulus is a even function, isn't it? So I can just bring this one constant outside and I will going to multiply with the number 4. Why? Because there are 4 sections here, clear. So I will going to integrate over single section here. Over this single section, x is ranging from 0 to 2 and y is also ranging from 0 to 2, fine. So I can write this one as y dx
dy. Now perform the integration here, 16 into x dx y dy. So here 16 into it is, sorry, there is no x here, there is a 1 here, so it is x. So the limits are from 0 to 2, here it is y square by 2. So the limits are from 0 to 2. Upper limit minus lower limit, it is 16 into 2 into 2 square by 2. So it is 16 into 4, which is equal to 64. It is given in the, obviously this will be in the order of microcoulomb per meter square. So if you find out the total charge, this will be the microcoulombs. So that is what mentioned here. So the 64, option A is the answer. Fine. Anyhow, there is a one more question here. This is related to the Ohm's law. So the electric field is applied. There is a cylinder here. Cylinder diameter is given. Fine. And it is said that this electric field is applied along the, that means it is electric field is acting axial to the conductor. Fine. So when the electric field is acting axial to the conductor, or when the electric field is given, you can find out what is called a here current density from the Ohm's law. J is equal to sigma into E. The conductivity is given here. So 5.8 into 10 to the power of 7 into the applied electric field, which is acting along the axis. This is how it is acting. Fine. So it is 0.01. Yes. So you can just check it out, this one. So this is 5.8 into 10 to the power of, it is 5, or 58 into 10 to the power of 4. So this is ampere per meter square, correct? But the question is asking for the current. So obviously you need to multiply with the surface area. So what is the total current? Actually you need to perform the integration. So as this current is acting over the, in the normal to the surface here, if you consider the surface here, so and that too it is constant, you can just multiply with the area here. So 58 into 10 to the power of 4 into, it is pi r square. Diameter is given, so you can check it out what, where there is a diameter given. So it is 0.5 into 10 to the power of minus 3 whole square. So I have its value, my calculator is showing its value as 0.4555. So approximately 0.5 amperes. It is a numerical answer type question. Maybe it may be asked to approximate it over the 2 decimal places. We do not have, as of now, we do not have any information regarding this. So 0.455 amperes is the answer. There is a one more question here related to the transmission line. It is asking what is the power delivered to the load. Fine. So here is the transmission line. So over the transmission line, so if it is a lossless transmission line, whatever the power you are supplied, you will find the same power over the length of the transmission line everywhere. Fine. So it is asking what is the, it is ZL, and this is having the characteristic impedance of Z0. So what is the power supplied to the transmission line is given. It has a 10 milliamperes. Fine. So it is asking what is the power delivered to the load. What is the power delivered to the load? Power which is given by power which is reflected back. This is the effective power which is delivered to the load. So how this can be written? You can include what is called a reflection coefficient concept here. So this part, a power incident into magnitude of the reflection coefficient is nothing but the percentage of power which is reflected back. So the incident power minus reflected power will leads to the power which is actually delivered to the load. So here you need to find out the reflection coefficient. What is the reflection coefficient, guys? ZL minus Z0 by ZL plus Z0, which is, what is the load here, guys? It is 50 minus J 75 minus 50 divided by 50 minus J 75 plus 50. So this will become minus J 75 divided by 100 minus J 75. So you can take the magnitude of this, which is equal to 75 divided by square root of 100 square plus 70 square, 75 square, it is 0.6. Clear? This is what I have its value. So what is the power actually delivered to the load? It is, the power which is supplied is 10 milli minus 0.6 square. So it is, check out this value, this is, it is 0.6. So you can check out, my calculator is showing it is 6.4 milliwatts. This is the power which is delivered to the load. Fine. So let us have one more question. This is a very simple straightforward question. So the two resistors are connected in the loop as, and the loop area is given into the 5 meter square. Fine. And the circular loop is placed in the xy plane. So here there is a circular loop, because of that there is a magnetic field. And what is the magnetic field? The magnetic field is this one, 0.5 into T Tesla. is applied, obviously if the loop is placed in the xy plane, you can put your thumb in the direction of the current flow, your fingers will going to show the direction of the magnetic field in the z direction, or otherwise in the question also it would have mentioned, yes, it is mentioned, it is the field is acting in the positive z direction. Anyhow guys, so you have got a magnetic field and is asking how much the current is flowing in the loop. First you can make use of what is called a Faraday's law. So the V is equal to, just the definition form is enough, so it is d by dt of psi m. So the magnetic flux density is given, you have to multiply with the loop area, so you are going to get the total flux. So which is equal to, how much is this, point t into t, the loop area is given in the question, so it is phi. Fine. So to calculate this one, it is 2.5, a differentiation of t is this one. So this is the voltage which is induced in the loop. I think we do not have any clarity regarding the, yes, it is said that it is a magnitude. Fine. So you have to take only the magnitude here. Fine guys. So this is a voltage which is induced over the loop. Fine. So what is the total current obviously flowing through this one? It is V by total. What is the total resistance of this one? It is a 4. So it is 2.5 divided by 4. You can check it out, this value. This value is 0.625 amperes. See here, this is what we have tried. This is what the input we have got from our students. Of course, there may be a change in some wordings, change in some difference in the, you may find some difference in the orientation of in the actual questions. Fine. So, but this is the essence of the questions. This is how you need to approach for the today's exam questions. Fine. Hope you people would have done well. I'll hand over the session to the other faculty member. Thank you. Good luck.
Yeah, dear students, we discussed two questions from electronic devices which are actually simple. I got one more input which is based on the diode current equation. Okay. So we know what is the diode current equation. So let me write, what is it? I is equal to I naught into e power v by eta vt minus 1, right. So in the question they have given the data related to this, the forward current that is going to flow, and what is the reverse saturation current also they have mentioned, and what we need to calculate is this voltage V. So this is what we need to find out. So it's actually again very simple question, right, related to your diode current equation. Just given the forward current, a reverse saturation current, we know what is the eta depending upon germanium. If it is, then it will be 1. For silicon you can take it as 2. Thermal voltage will be 26 millivolts, and based on that you can calculate what is the value of V. So if any further questions we have, we will update. Thank you.
Right, good evening students. Let us discuss about the questions given in communication systems. So, as per the inputs given from our students, we are having around 6 1 mark question, 2 marks questions, and 4 1 mark questions have come. So, totally we are assuming around 16 marks weightage from this topic. As of now we have got only 5 questions. So, I am going to discuss only those questions. Okay. All these are the data supplied by the students. So, let us go through these questions. Generator matrix of a 6×3 binary linear code is given, and what is the minimum having distance between the code words. So, most probably this might be a 2 marks question. So, you can see very clearly this is the identity matrix, and this part of the matrix is your parity matrix. Okay. So, if you take the parity equations, so first parity equation, if you take the column matrix, this is like D1 XOR D3, and if you take the second parity equation, this is like D2 XOR D3, and if you take the third parity equation, this is like D1 XOR D2. Just based on this column matrix, wherever one is there, I supplied that values. So, if you take your data, you are having 0 0 0 1 1 0 1 1 with MSB as 0, and again 0 0 0 1 1 0 and 1 1 with MSB as 1. These are our 8 combinations of data. So, this is like taking D1, D2 and D3, and our parity equations we have to develop based on the given equations. So, if you take the parity equation for the first one, anyhow all these are zeros, so you will get zeros only. Then if you take D1, D3, it will become 1, D2, D3 it also becomes 1, D1, D2 it becomes 0. So, like this you calculate all the combinations. Okay. I have taken that, I am just writing here to complete in quick time. So, this becomes 0, 1 1, 1 0 1, then 1 0 1, 0 1 1 1 1 0 and all zeros. So, these are the parity equations we are getting as per the data we have. Now, you simply calculate a Hamming distance. What is Hamming distance? It indicates the number of ones coming in your given code word. So, these are my 8 code words. So, how many number of ones I am having? In the first code word it is 0, then it is 3, then it is 3 again, then 4, then 3, then 4, then 4 again, and last is 3. Clear? Now, what is your D minimum? D minimum is nothing but the minimum Hamming distance except for a non-zero code word. So, that is the definition of D minimum. Hamming distance minimum value except for all 0 code word. That is all. So, if you use this simple definition, what is the value of D minimum that you are going to get? That will be equal to 3. So, the value of D minimum equals to 3. So, based on this, your error detection and correction capabilities will be defined. Clear? It basically, I do not think it is a 1 mark bit, definitely it should be a 2 marks question. Okay? Right. Let us see the next bit. This is straightforward, most of the case I think it might be a 1 mark question. So, see the data, modulated signal of an FM is given, and he is asking the peak frequency deviation of the FM signal, that is a bit. So, what is the frequency deviation? First of all, if you take a instantaneous frequency deviation, it is 1 by 2 pi d by dt of instantaneous phase deviation. So, what is this instantaneous phase deviation? It is nothing but 3 sin 2 pi f1 t plus 4 sin 6 pi f1 t, both f1 only, it is not f1 and f2. As per the data provided, it looks to be both as f1. So, if you take this delta fi of t, you will get a 1 by 2 pi into, when you take the derivative of this function, you will get a 6 pi f1 into cos 2 pi f1 t plus 24 pi f1 into cos 6 pi f1 t. So, when you divide this with 2 pi, you will have 3 f1 into cos 2 pi f1 t plus, how much you will get? 12 f1 into cos 6 pi f1 t. Now, both these components are cos functions operating with same frequency f1. So, peak values itself will become their maximum values. So, if you take a delta f max, this value would become 3 f1 added with 12 f1. So, value becomes 15 f1 hertz. That is all. So, your answer will be choice C. Okay. This is come from frequency modulation topic. Let us see the next bit. This is definitely a 2 marks bit, no doubt. Very good question. X and Y are Bernoulli random variables taking values 0 and 1. Only 2 values are there. Joint probability mass function. Probability mass function means for a discrete random variable, mass functions are also called as density functions. So, you are having a random variable x and random variable y taking values of 0 and 1, and x is also taking values of 0 and 1. So, joint probability matrix of x and y is given to you, that is what he has given. So, what are the values? 0, 0 is 0.06, then x0 and y is 0.14, then x1 and y0 is 0.24, and this is 0.56. Okay. So, this is your joint PDF. Now, what is the mutual information? So, what is mutual information? It is the information transfer happening between x and y. You can write this as h of y minus h of y given x. This is the formula. Okay. So, I need h of y and I need h of y given x. So, for finding h of y, you need probabilities on y. So, what is the probability on y equal to 0? Independent of x, you take y equal to 0. So, this value becomes 0.3. And what is the probability of y equal to 1? It becomes 0.7. So, what is your h of y? So, this will be minus of 0.3 log 0.3 to the base 2 plus 0.7 into log 0.7 to the base 2. So, if you simplify this value, you will get a value of h of y as 0.8812. This is what I am getting. Okay. Now, h of y given x also you have to find. H of y given x is a conditional probability. So, this is like a minus summation on integer values of both x and y, joint probability matrix of x y into log of p of y given x for different values of x and y. So, this is the formula we have to use. So, you are having x 0 to 1 as well as y also from 0 to 1. So, multiply joint probability with conditional probability taking the log value. So, if you do this calculation on all values of x and y, you will get a value of 0.8808. Is it clear or not? So, you have to be very careful in doing this because you have to take conditional events. What are these conditional events? Suppose you want a probability of y equal to 0 given x equal to 0. This is nothing but joint event probability of x equal to 0, y equal to 0 divided by probability of x equal to 0. So, like this you have to calculate all the 4 conditional events. First you have to do this. Okay. Once you complete this, then only you can substitute in this formula and then do the remaining calculation. It is a time taking question, no doubt, but carefully do it. Now, if you take the difference between these two, then I am getting a value which is 0.0004. So, hopefully this will be the right answer. So, fill in the blank, no options are given. So, this is how you have to do it. Let us see the next bit. This is also based on information theory and coding part. A random variable x takes values of -1, 0 and 1. So, x is a discrete random variable taking values of -0 and 1, and the probabilities on x means its density function is alpha, 1 minus 2 alpha and alpha. This is the data given. Now what is he saying? If g of alpha represents the entropy of x, then which of the following conditions is true? So the exact question, what is the data that is there, I also do not know. This is the data we got from our students. So as per the statements given, you can see he is calculating a entropy, whatever g he is talking here is entropy, and it is a function of what? It is a function of alpha. Alpha is nothing but your probability. Now you are having 3 events or not? So what is the maximum possible entropy? Will be possible, H max will occur at alpha equal to 1 by 3. Is it correct or not? Correct or not? When all the events occurring in that random experiment happens to be equal, then entropy of that particular random experiment will reach maximum. So 1 by 3 is around 0.33. So before 0.3 also it will be less than peak value, after 0.3 also it will be less than the peak value. Correct or not? So if you compare g of 0.3, around 0.3 with a value less than that or a value greater than that, it should be definitely less. So g of 0.3 should be greater than g of 0.4. Is it true or not? 0.4 is a value coming after 0.33. So definitely it will come down. So you can choose this C, there is no doubt. Similarly, if you take a 0.3 and 0.25 and do a comparison, 0.25 value whatever you get, it will also be less than the value you are getting at 0.3. So this can also be correct. But you see the remaining two, there is no chance that 0.3 is the maximized value, 0.33 or 0.3, but 0.25 less than that, so there is no chance. And here also the same thing, after 0.33 the probabilities, when you substitute and calculate the entropy, it will keep on coming down. So both B and C can be the possible choice. This is how you can analyze based on the number of events that you are given in your function. Let us see the next bit. Now see this question, this is a very good question, most probably it might be a 2 marks bit only. So what is he saying? F of t is alpha k p of t minus nt, where alpha is representing 0 mean and unit variance, and this is the pulse he is showing here. Now if you observe carefully, I have explained these type of models in class also. This is mostly representing a random number generator. These type of cases, it is like representation of a random number generator. Okay. So that random number generation, we are representing a pulse whose amplitude is 1 in a duration of 0.5 t. That means in this particular function, this is representing your pulse. Okay. So that pulse is a deterministic function. Okay. But whatever the coefficient of that pulse you are having, that alpha, that means what? This is representing a probability. Okay. And this is nothing but your random variable. So that can take any value from 1 to n. So that means you can represent any coding here. That means whatever this f of t is given to you is like a random process. So I am having a random process here. So there might be so many events here. Okay. So what we are doing, we are taking once as a function of time. Let us assume the pulse we are showing is for duration 0.5 capital T seconds. Now some probability might come. Let us assume you are getting for alpha 1. Then at the next interval, what is happening? This is getting shifted right side by n equal to 1. If you substitute, then this will become 1, this will become 1.5 t, and it may have a probability which is alpha 2. Similarly, when you shift one more time, then what will happen? It will get shifted right side by 2 times. So this will become 2 and this will become 2.5 capital T, and it may occur with a probability alpha 3. Is it clear or not? So whenever you are taking these events from your sample space, this is what we call it as ensemble. Okay. And all these are different events which are occurring as a function of time. So, whatever the final output we are getting is a random process in which the pulse is a deterministic function, but it is occurring with certain probability. So, this is what you have to understand first. Okay. Like-minded random variables occurring with a deterministic pulse. Now, what is he asking? The mean value of the random process. So, now he is talking about random process is independent of capital T, and autocorrelation function of f of t is independent of capital T. Which of these statements are true? So, here if you see carefully, if you take the function, let us assume at some time instant t equal to t1, that means what I am doing? I am considering my random process at certain time instant t equal to t1. So, when you take this random process and calculate mean of each of these random variables, what is the mean of your random process? Expectation of f of t will be expectation of your random variable or not? Correct or not? Because there is no expectation on a deterministic function, that expectation will be only on a random variable. Now, he only gave that random variable is having 0 mean. That means, even if your expectation of this random variable you calculate, it should be definitely a constant. There is no doubt it will be a function of t. So, mean of f of t is independent of t. That statement is perfectly true. Now, what is the second bit? The autocorrelation function of f of t is independent of t. Is it true or not? Now, let us assume I am sampling once again the random process at a time instant which is t equal to t2. Because autocorrelation function, if you want, you should take a time shift tau. So, t1 is my first time instant, t2 is my second time instant. So, if you take the difference between these two time instants, this value is what we are writing as tau. So, if you calculate the autocorrelation function in this time range, very clearly you can see definitely it is depending on that sampling instance which creates that tau, which is a function of t or not. This can be anything, which will be again a value between 0 to 0.5 t. That means, whatever autocorrelation function f of t is there, it is becoming dependent on t. It is not independent of t, it is dependent of t. So, definitely you can say that S1 is true, but S2 is false. So, these are all the memory based questions that we have in communication system as of now. So many questions have come, but once we get the data, we will definitely give it to you. Hope you have done well in the exam. I wish you all the best. My next colleague will take the remaining part. Thank you.
let us see questions on digital circuits based on our students' memory. So, there is a question on sequential circuits, a positive edge triggered sequential circuit is shown below. There are no timing violations in the circuit. Input P0 is set to logic 0 and P1 is set to logic 1 at all times. The timing diagram of the input select line as well as S are shown below. The sequence of output Y from time T0 to T3. So, we need to write what is the Y at T0, T1, T2, T3. So, if you are observing that at select line 0 we are getting P0, at select line 1 we are getting S signal, and when you are observing this in second circuit, second flop, so select line is 0 we are getting P1 and select line is 1 we are getting output of first flip flop, and these two are XORed. That is what we need to write output waveform. Then we see what can be the Y at T0, T1, T2, T3. So, if you see in this select line, first positive edge triggered flip flops. So, at every positive edge we see what is that first flip flop output. So, at positive edge, so select line is 0. When select line is 0, we are getting S is the output. So, what is that S here? If I say here output of the first flip flop, if I say Q1. So, at first positive edge trigger, positive edge, select line is 0, then we are getting S means it is 0 itself. So, at second positive edge, select line is 1, then we are getting P0 means P0 is also 0. At third positive edge, select line is 1, again P0 is the output of first flip flop. At fourth negative edge, select line is 0, then again we are getting S. What is the S we have here at this edge? We are getting 1. So, this is the output of first flip flop. If you are observing second flop, select line is 0, we are getting P1 which is 1, and select line is 1, we are getting first flip flop output which is Q1. So, let me draw that second flip flop output Q0 based on select line. So, when select line is 0 at first positive edge, we are getting a 1. So, at this positive edge we will be getting 1, assuming initially it was 0. So, right, at positive, first positive edge select line is 0, we are getting P1 means P1 is tied to 1, it is logic 1. At second positive edge select line is 1, then we are getting Q1. What is Q1? At this second positive edge it is 0, so it is going to be 0. It is going to be 0, and at third positive edge select line is 1. When select line is 1, it is going to be P1 means it is going to be, let me say here, at third positive edge select line is 1. When select line is 1 is again Q1 itself. So, it is going to be 0 itself. At fourth positive edge select line is 0. When select line is 0 we get P1. So, it is going to be this, it is 1. So, these are Q1 and Q0. So, we need to get that XOR of that Q1 bar and Q0 bar. So, if I take that XOR gate with Q1 bar and Q0 bar, it is Y, and similarly we can apply that right Q1, Q0 also, it will be same output. So, you can take XOR of these two, or you can take XOR of complements of these two, functionality will be same. Then apply that XOR Q1, Q0 XOR, it is going to be Y, it is 0, and here it is right 1, and it is going to be 1, and it is going to be 0 and 0, 0 continuously. So, this is going to be the Y output. So, if you are observing that it is T0, at T0 it is going to be 1, at T1 it is going to be 0, at T2 it is going to be 0, at T3 it is again 0. So, what we get here at T0 it is 1, T0, T1, T2, T3 if you are observing. So, at T0 it is 1, T1 it is 0, T2 is 0, T3 also 0. This is what we get according to the waveforms we have as per memory, right. So, let us see next question. It is also very simple question. A 3 input majority logic gate has inputs X, Y and Z. The output F of the gate is logic 1 if 2 or more than 2 inputs are logic 1. The output F is logic 0, it two or more of the inputs are logic 0, which one of the following option is a Boolean expression of the output f? So if you observe this, which we have already discussed in the class, so x, y, z, and if I say that f, so 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So if majority ones are there, then output is 1, otherwise it is 0, means it is 0, 0, 0, 1, 0, 1, 1, 1. So if you say this combination numbers 0, 1, 2, 3, 4, 5, 6, 7, f is equals to sigma m of 3, 5, 6, 7. If I use a 3 variable K map with x, y, z input variables, x, y, z, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. So 3, 5, 6, 7, if you minimize this, we get y is equals to xy plus yz plus zx is the Boolean expression of f which is expected. So answer is A for this question. Right. See another question based on maximum clock frequency. In the circuit shown below, the AND gate has a propagation delay of 1 nanosecond. The edge triggered flip flops have a setup time is 2 nanosecond, hold time is 0, clock to Q delay is 2 nanoseconds. The maximum clock frequency in megahertz such that there are no setup violations. So as per our discussions, what we say here, how many paths are there? It is one path, it is a second path, we know. So we need to calculate minimum clock period of these two independent paths. If I say that minimum clock period of path 1 T1 is equals to flip flop delay, there is no combination in between, and setup time of this. So obviously 2 nanoseconds plus 2 nanoseconds, it is going to be 4 nanosecond minimum clock period of path 1. If I calculate minimum clock period of path 2, which is T2, if I say that flip flop delay, AND gate delay, and setup time of the capturing flip flop. So obviously 2 nanoseconds plus 1 nanosecond plus 1 nanosecond, sorry, 2 nanoseconds is setup time. So going to be 5 nanoseconds. So with these the critical path we can calculate the minimum clock period of entire circuit is obviously right 5 nanoseconds, and maximum clock frequency f max is equals to inverse of T minimum. So it is going to be 0.2 gigahertz, which is going to be 200 megahertz. Answer for this question is 200 megahertz. So what we are observing here, so if there is a flop to flop communication, flip flop to flip flop, right, flip flop delay, comb delay, setup time, and then flop delay, comb delay, setup time. So we are calculating minimum clock periods of individual paths. Then we are observing which is the critical path which is going to decide minimum clock period of entire circuit as well as maximum clock frequency. Then let us see next question. A 10-bit analog to digital converter has a sampling frequency of 1 megahertz and a full scale voltage of 3.3 volts for an input sinusoidal signal with frequency 500 kilohertz. The maximum SNR in dB and the data rate at the output of the ADC are. So if you observe that the maximum SNR is equals to for n bits 6.02 into n plus 1.76. So if I say that n is equals to 10, so we can say that 6.02 into 10 plus 1.76. So it is going to be 60.2 plus 1.76 is going to be 61.96 decibels, that is maximum SNR. So 61.96 we have in two options, we have to choose only one, so it is MCQ. So then next one is what is the data rate at which we are getting output at this ADC output. So for this what is the sampling frequency, we are observing that 1 megahertz, and 1 megahertz is the sampling frequency, and each sample is converted into 10 bits. So number of bits we are getting at output of this ADC is so one sample into 10 megabits per second. So it is right 10 megabits per second. So, answer is going to be 61.96 is SNR and 10 bits, 10 megabits per second is the data rate we are getting at analog to digital converter output. Then let us see next question. So, a 4-bit weighted resistor DAC with inputs B3, B2, B1, B0, MSB to LSB is designed using an ideal op amp as shown in the figure. The switches are closed when the corresponding input bits are logic 1 and output is and open otherwise. So, when the input B3, B2, B1, B0 changes from 1110 to 1101, the magnitude of the change in output voltage. If you are observing that output voltage is equals to, so minus R into, so B3 VR, so divided by R plus B2 VR divided by 2R plus B1 VR divided by 4R plus B0 VR by 8R. So, if you are observing that for, let me calculate for 1110 and 1101 also. So, if you see here, output voltage is equals to minus R into, so for 1110 if I am calculating in the data, if you are observing what is that here. So, VR is how much is that 2 volts divided by R. So, let me say that 2 volts divided by R plus next bit is also 1. So, obviously it is 2 volts divided by 2R, next bit is also 1, 2 volts divided by 4R plus next bit is 0, that is the voltage we get. So, what we get here, RR gets cancelled, it is minus of 2 plus 1 plus 0.5. So, it is nothing but minus 3.5 volts, we are getting that minus 3.5 volts. For 1101, if I calculate output voltage for 1101, so it is going to be minus R 2 volts divided by R plus 2 volts divided by 2R plus 0 plus 2 volts divided by 8R. Then it is going to be right minus of 2 plus 1 plus 0 plus 0.25, it is going to be minus 3.25. So, the difference we are observing that it is 0.25 volts. How much it is changing here? Output change, if you are observing, it is 0.25 volts, it is equals to 250 millivolts. The answer is 250 millivolts. The change we can observe here, it is 250 millivolts. Let us see next question. It is a very simple question directly from our discussion. A full adder and XOR gate are used to design a digital circuit with inputs X, Y and Z and output F as shown below. The input Z is connected to the carry input of the full adder. If the input Z is set to logic 1, then the circuit functions as. If you know that, so it is X, it is Y and it is Z. So, Z is connected to 1, if you are observing that, so if Z is 1, what is the input we are getting here? So, Y bar, we are getting here Y bar and also we are connecting here it is 1. So, output of this circuit is going to be right X plus Y bar plus 1. If I say that X plus Y bar plus 1, we can say it is 2's complement of Y, then it can be used as X minus Y. Once again here, if you are observing as Z is equals to 1, it is passing that Y bar as operand and Z equals to 1. So, obviously X plus Y bar are the operands and input carry is 1. Obviously, X plus Y bar plus 1 means X plus Y bar plus 1 can be named as 2's complement of Y. So, X plus 2's complement of Y is nothing but X minus Y. So, it is going to be a subtractor. Answer is A.
Hi friends, last but not least, okay, general aptitude. From the memory based we reached to 2 questions only. One of the question 3, 9, 19, 33. What is the next number? Number of times we discussed in the classroom based on the numbers, difference increase, difference decrease, difference multiplication, this type of concept. 99% is very easy, apply the difference. Difference 6, next 10, next 14. Now observe 6, 10, 14. Next difference 18. So add these two, 51 is the answer. Okay, this is one problem. Next, another one. So based on the probability concept, my dear friends, based on the probability, we have total 4 balls. Total 4 balls. Out of the 4 balls, 2 red, 2 blue. Okay, 2 red, 2 blue. You pick only 2 balls. You pick only 2 balls. Okay, 2 balls not at a time. Okay, 2 balls not at a time. So one after one. So one after one. I want one red, one black. Okay, repetition not allowed is here. Okay, one after one. So I pick a 2 balls. I pick a 2 balls means what is the probability? So total 4 chances. I want one red. I want one red means what is the answer? Out of 1. Okay, 2. Next, I have only remaining 3 balls, and another one is compulsory. I want blue. Okay, I want blue. So then again, I want blue 2 out of the 3 chances only. This is repeated 2 times. This is repeated 2 times. Are you getting the point? I mean, first one red, next one blue, next one blue, next red. I like 2 chances we are getting. So 2, 4, 2 2s are cancelled. What is the final answer? 2 by 3 is the probability. Okay, friends. Okay, 2 by 3 is the probability. Same question, you can elaborate number of ways. Okay, this is one of the best way. Okay, friends. Next, these 2 questions only we are getting from the memory based only, and another some of the questions are there, and this is purely memory based concepts only. After getting the response sheet, we are giving the complete clarity. Okay, we are giving the complete clarity. I hope everybody doing the best. Okay, each and everybody also get good rank, friends. All the best. Thank you from us.